Lesson 81, central angles and arcs. First off, let's look at what are arcs and angles. So to review that, all circles have a total of 360 degrees. And the circles can be divided into sectors, or sections of a circle with two radii. Radii, or radius, would be one part from the center to the outer part of the circle. And then we have another one over here. So there's our two radii. Forms this whole piece. So this whole thing would be one sector. The central angles are those angles whose vertex is the center of a circle. So right here, here's your central angle. And the central angle is going to be the same as the degree of your arcs on the outside here. So they are the same. So whatever the degree is for the central angle, it's the same degree for the arc. And then we can describe the arc in two different ways. The arc is the outer part of the circle. You have a major arc, which means the arc is greater than a semicircle. So it's more than half a circle, or we would call it a minor arc because it's less than a semicircle. So this piece right here, this arc is less than half. So this would be a minor arc. And this arc way up here is more than half a circle. So we would say this would be a major arc. So now let's take a look at an example. So let's draw a circle with central angles that divide the circle evenly into thirds. So we have a circle here. We want to divide that into thirds. They started off for us. We just need to draw two more lines. So maybe draw this one and here. So we have three pieces. Each one is a third of the whole circle. And so if the whole circle is 360, and I divide that into three equal pieces, that means each central angle would be 120 degrees. Because if you were to add all of them up, that would give us your 360 degrees. Next one here says the court of a playground is painted on the blacktop. The court is formed by a circle with two intersecting diameters, forming four central angles. One of the central angles measures 50. Find the measures of the other angles. Well, if we look carefully here, if this piece is 50, this piece is exactly the same as that one. We would consider those vertical angles. So if this is 50, this has to be 50. And if those are 50, those two pieces are equal, we know that this angle and this angle are the same. So now we know all angles equal 360. We have two groups of 50, which is 100, plus we have two groups, and we're going to call this x. So we have two groups of x. We want to find out what is x. I'm going to subtract 100 on both sides. And I'm left with 260 equaling 2x. To get x by itself, I divide by 2. X would equal 130 degrees. So this is 130, this is 130. So our measures the other angles, we have 130, 50, 130. Next problem, a circle is divided into eighths. What is the measure of each acute central angle? Again, all the angles add up to 360. I divided it because it says they divide into eighths, which means they divide into 8 equal pieces. We take 360 divided by 8, and that gives me 45. So that means each angle is 45 degrees. Next one, what is the measure of arc AD? So we want to find out this piece in degree. Well, if we think back to the first slide we went through, we said the central angle is the same as its arc. So if the central angle is 60, the arc of AD has to equal 60 degrees. Next part, what fraction of the circumference is the arc intercepted by angle ABD? ABD. We want to know what fraction of the circumference. Remember, circumference is pi times diameter. So if the radius is 6, the diameter has to be 12. So 12 pi is the diameter. We need to find out what fractional part of the circumference is that arc. First off, we need to know what fraction is this piece. So if that is 60 out of 360 degrees, if I reduce this by 60 over 60, that gives me 1/6. So this is 1/6 of the circle, this sector. So if the circumference is 12 pi, 1/6 of that would be a fractional part of the circumference. So we need to find out what is 1/6 of 12 pi. So to do that, I can do 12 divided by 6, and that gives me 2. We would say it is 2 pi. That's the fractional part that this arc is covering. So 2 pi of the 12 pi is that section. And then it says if the radius of the circle is 6 centimeters, what is the length of the arc in terms of pi? And actually, I've actually found that this part would be 2 pi because the fractional parts I found was 1/6. So to find the fractional part, just take the degree of the central angle, put it over a total degree of the circle, and reduce. So that's 1/6. And then what I found was the 2 pi is, that's the length of the arc in terms of pi. So that's what this piece is. This piece is 2 pi. If I have 6 of those around here, 6 of those 2 pi's would give me 12 pi, which is the circumference of the circle, or the perimeter of the circle. And our last problem, what is the measure of arc CD? We need to find out this piece. In order to find that in degrees, I need to know what the central angle is. But first, I need to count how many sections or sectors we divide the circle into. So 1, 2, 3, 4, 5, 6, 7, 8. We had 360 degrees. We divided into 8 sectors. So 360 divided by 8 gives us 45. So the central angle is 45. That means the arc of CD is 45 degrees. What is the measure of major arc CD? So this piece, this is the minor because it's less than half a circle. The major would be going the opposite direction from C to D. So if the degree, the whole circle is 360, and you take 45 degrees away, what is left? 360 minus 45 gives us 315 degrees. So the measure of major arc CD would be 350 degrees. And then the last part says if the diameter of the circle is 20 centimeters, what is the length of arc CD? Use 3.14 for pi. We need to find this in length of centimeters. So the diameter is 20 centimeters. So let's do 20 times 3.14 to find the perimeter of the whole circle. And then we're only finding, since we divided by 8 pieces, we're actually going to divide that by 8 because this is 1/8 of the circumference. So now we have 20 times 3.14, which is 62.8, divided by 8, gives us an answer of 7.85 centimeters. So this is what this piece right here would be. So that is our lesson today on central angles and arcs.